Welcome in, everyone. In this video, I'm going to go over many concepts regarding circles. The first thing I want to talk about is what makes a circle. The next thing I will go over is the equation of a circle. Then we'll go on to identifying characteristics of a circle and writing equations for circles. Let's get into it. What makes a circle? So geometrically speaking, a circle is the boundary consisting of all points equidistant from a fixed point. And thankfully, in geometry and in algebra, we use the same vocabulary. So the fixed point that we're talking about here is the center of the circle. Now the circle itself is the boundary here. And we can only get this boundary if these points are all going to be the same distance from the center, aka equidistant. And the equidistant is referring to a distance, and that distance we will call a radius. And on the next slide, we will be having an equation that relates the center and the radius together so that we can look at the graphs of circles on a coordinate plane. As promised, here is the equation of a circle. We have x minus h, the whole quantity being squared, plus y minus k, the whole quantity being squared, equal to the radius squared. Now, where do all of these extra letters come into play? H, K, R? Well, as mentioned on the previous slide, there are two very important characteristics of a circle: the center and the radius. So we can find the location of the center if we know the equation by taking the opposite of these numbers in the parentheses. And in fact, if we know the center, we can go backward as long as we take the opposite of these values and put them in parentheses with x and y accordingly. And remember, the ordered pair is ordered as x comma y, so that's why h is paired up with x and k is paired up with y. Now the only other part to a circle that we've got to talk about is the radius. And when you go from the equation to finding the radius, you will have to take the positive square root of what's in the equation. And if you're going to go backward, then you will have to square r to get the r squared. Now, some of you might notice this is very similar to yet another property or theorem that you already know within the math world, and that is the Pythagorean theorem. It's coming back again in full force. We have something squared plus something else squared, equaling to a third value squared. Now, isn't that interesting? The Pythagorean theorem, you say? I can hear all of you out there. What? Yeah, this is related to the Pythagorean theorem. And here's how. So in front of you, I have a circle with a radius from the center going straight to the right and straight to the left, otherwise known as a diameter. And from here, if you can imagine, we extend this out horizontally and horizontally. This could remind you of something like the x-axis. And in fact, we could do something like this for the y-axis as well. So here is a vertical diameter, that we could think of as the y-axis. And Yeah, I can start saying things like this circle is centered at the origin, but we're not really worried about that right now. What I am more worried about is the fact that I can draw any radius I want. So I'm going to draw one from the center out to the circle here. I'm going to draw one from the center out to the circle over here, a little bit flatter. Sure, I'm going to draw another one right here, and I'll draw one more over here. Oops, that's not, there we go. And one more over here like this. There we go. With each of these radii, I can come back and create a right triangle. There we go. If I go down straight to the x-axis, or up to the x-axis in these other two cases, there we go, there's a right triangle and another right triangle. And what all of these right triangles have in common is the fact that the hypotenuse are all the same length. But the sides, the short leg and long leg, or maybe the same leg in this case, the sides, the two legs, are changing. So this is very closely related to the Pythagorean theorem. On this slide, we're going to start identifying the characteristics given an equation. So in front of you, you see the equation of a circle. X minus 5, the entire quantity squared, plus y plus 9, the entire quantity squared, equals 64. So all we have to do from here is figure out what are the opposites of these numbers, and as long as we put them in the correct order, remember x's before y's, we can find the center of the circle. So the opposite, and I mean the entire number in here, including the sign, the opposite of negative 5 is a positive 5, and the opposite of positive 9 is negative 9. Boom, center. From there, the only other thing that we will need to find is the radius. And remember, the radius is just the number that's all by itself in this equation, lonely radius. But you'll have to take the positive square root of that number to find it. So the radius in this equation is 8. On this slide, we're also going to be identifying the characteristics. Now, one thing that I have not mentioned up until this point is that the circle is quadratic in both the x variable and the y variable. And in this scenario, we don't have a very good setup to just look at it and say, well, I know what the radius and the center are going to be just by taking the opposites and the square root of a number. But we have a method to find the radius and the center. First thing I want to point out, this doesn't always happen, but it can happen. If you take a look at all of the coefficients on the variables here, as well as the number on the opposite side of the equation, they're all even. So you're going to want to divide all terms by 2 to make this next step possible. There we go, that's much nicer. Okay, in order to get a nice little set of parentheses with a binomial in it squared, we're going to have to do some work. And in fact, going from a couple of terms like this into a binomial squared means we're trying to complete the square. So I'm going to go ahead and write down a little bit of space here. Let's see, x squared plus 8x. The third number we add is always going to be a positive, so plus y squared minus 2y plus a number equals 11. And since we're adding numbers on the left side of the equation, we will have to add both of those numbers to the right side of the equation. So let's get some blanks over here as well. Awesome. So how do you figure out what number goes in here? You take half of the b value. That's a positive 4. Let me write that a little bit further down. Let's see, positive 4. And then you have to square that value and get 16. Cool. And we're just going to do the same thing here. I'm going to take half of -2, that's a -1, and then I'm going to square a -1 to get +1. So over here on the left side, I'm going to add 16, and I'm going to add 1. From here, we know that these three terms will factor nicely. And as a matter of fact, these three terms will factor nicely. And we've already done most of the factoring. All we have to do is put an x in front of this 4, square that. We've got to put a y in front of this 1, square that, add it together, and add these numbers on the right side of the equation, 28. Now this is in a form where we can find the center and the radius. So the center here, we just have to take the opposite of that number in with x. That'll be a -4. The opposite of this number is +1, and boom, you've got a center. The radius, on the other hand, we're going to have to do a little bit of work, because if you take the square root of 28, the positive square root of 28, you're going to get the square root of 28. But that can simplify down to 2 square root of 7. So make sure you make the simplifications when necessary. For the last section of this video, we're just going to be identifying the characteristics of circles. And really all that means is locating the center and finding what the radius is. So don't be that person, haha, there's the center, I found it. No, we can't just do that. We've got to be able to have the coordinates of the center. So you can start at the origin and just count 1, 2, 3, and down 1. So the center is located at 3, -1. The only other thing that we need to do here is find the radius. And so what that means is we start from the center and we can draw to any of these points that you see drawn on the circle, because vertical and horizontal movements are going to be the easiest to calculate or count when we're working on an actual coordinate plane. So I think I'm going to try my hand at this one over here, and I'm just going to connect these two with the line, which would be the radius. So all we have to do is count how many units does this line span. So it starts here, it goes 1, 2, 3, 4, 5. It looks like it lines up there pretty well. Maybe we go to one other point just to make sure that we counted correctly. So there's that one. I'm going to go ahead and draw my line from there to there. And maybe I just count, let's see, it starts here, right? 1, 2, 3, 4, 5. Is that where we get to stop? Yep. So yeah, the radius here will just be 5. And again, when you're doing this, just make sure you're moving either horizontally or vertically to find the radius. Using the information from that last example, we know that the radius is 5 and the center is at 3, -1. What would the equation of this circle look like? Well, you just have to remember the following equation, right? Remember, it's kind of like the Pythagorean theorem, so it's going to be something squared plus something squared equals another thing squared. And in these parentheses, we have x and h, and in the second set of parentheses, y and k, and then the radius is all alone. Poor little radius. So from here, you need to remember that the actual center, the coordinates of the center, are h and k. So we can take the opposites of these numbers, and the reason we take the opposites of these numbers are because of the subtractions, and we take the opposites of those numbers and substitute them right into the equation for the circle, as well as the radius. Now the last part here is just the square of the radius, so it'll be x minus 3 squared plus y plus 1 squared equals 25. All right, so one thing I want to point out graphically, I keep saying it's the opposite, it's the opposite, it's the opposite. One thing I want to point out, though, is the following. You notice how in the set of parentheses, there's an x minus 3. So we can think of the opposite a couple different ways. If you take that x minus 3 and set it equal to 0, you will get that x equals 3. And the same thing for the y set of parentheses. If you have y plus 1 and set it equal to 0, you will get y equals negative 1. So effectively what that is doing is it is telling us this. If we start at the origin and we want to find the center of the circle, it's moved a little bit. It moved this far in the x direction, and it moved this far in the y direction, but opposite from what you see here, right? And this is why it's opposite down here. But if you take a look even, it says take your x coordinate of where the center should start at the origin and move it right 3. The opposite of left is right. So move it right 3. So we would be right there. Then it says take the y coordinate and move it down 1, because the opposite of plus 1, up 1 is down 1. And boom, there's the center. And this won't be the last time that you encounter this. This is what we call a translation, and it often gets applied to parent functions. Last example here. If you are given just the coordinates of a center and a radius, oh, that's kind of a sad looking radius. Maybe we can cheer it up a little bit, make it whole. You just need to remember that the equation, again, is x minus h squared plus y minus k squared equals r squared. So again, we can just take these numbers and substitute them in here, and the numbers will flip automatically. Subtracting a negative becomes addition. That's another reason to think of how or why you take the quote opposite. Plus y plus 2 squared equals, and this is where it gets interesting, 4 square root of 3 squared. Now, with this 4 square root of 3 squared, since these are being multiplied, we're able to distribute the square to each of those. So this is really 4 squared times root 3 squared. And 4 squared is 16, and root 3 squared, roots and squares undo each other, give you a 3, and that gives you 48. So 16 times 3 is 48. And then the rest of this equation just comes along for the ride. So we have x plus 7 squared plus y plus 2 squared equals 48 would be the equation for that circle. I hope this video helps you out. Thanks for watching.